So we said when we move just 3 disks, it should be easy. It should not take more than 7 moves. And we can test that on the application online here. It should not take more than 7 moves. But when it gets bigger, like 4 disks, it's going to be more complicated, like 5 and so on. But this application will find a solution for you. So fortunately, the problem has an inherently recursive nature, so which leads to the straightforward recursive solution. So let's find the best case first. So we said best case for the problem is n equals to 1. If n equals to 1, you could simply move the disk from A to B. Right? When it's last one, we just move A to B. Just like if we said Tower Paranoid has cannot reduce to 1. But if you have just one, just that, done. Right? If you have only one disk. Right? So that means always going to move that way. Right? When n is greater than 1, you could split the original problem into the following 3 sub-problems and solve the sequential, right? Move the first n minus 1 disk from A to C recursively, right? N minus 1 disk from A to C recursively. Because it's going to get to the smaller version again and again, right? With the assistance of Tower B, we need Tower B to help. And move the disk N from A to B. Right? So this from A to B. And then move n minus 1 disk from C to B. Exactly, if you look at this, A to B. And move this back to here. Right? So that's how we solve the problem, right? Right, so first, move that to C, and then move, right, from A to B, right? A to B, the last one, right? Or whatever number it is. And then move that stack back, right? So that's pretty much all the cases. And then you just do again, repeating over again. Move this to this, right? Right? And target is there, right? So that's what I try to tell you. Just repeat it again and again, doing the same thing over and over again. With an assistant of the Tower B. So now let's see. We're going to write this one by using the recursively helper method, right? So we're going to have the move disk method. And in n is the number of disks. And the tower A, B, and C, right? I mean, form, 2, and aux, right? Form, 2, and aux. Now, we're going to come back to if it's equals to 1, right? That pretty much just the best case is done. Just move the disk 1 from the form to the 2 tower. Else, we're going to recursively call move disk. Right? And this is the cases that we talked about just now. move n minus 1 this from A to C. So form, right, n minus 1 this, from tower to tower is going to be from A to tower, which is based on by using tower B as an assistance, right? So now we're going to move this n from tower to the to tower from here, right? Because now your 2 tower is your ox, correct? And then lastly, you're going to move n minus 1 this from C to B recursively, right? So that pretty much just from ox to 2 tower. You're just switching this tower here. And once it's done, you pretty much just put in the program, and program just called move this. But this move this pretty much give you the original tower A, B, and C. And then if n equals to 1, it's pretty much just move this n from, let's move this one from tower, like from B to from tower, actually from A to C, right, to tower. So let's test with the 4 disk and use this instruction. Okay, and see if we get the answer. So we're going to do 4. It say move this one from A to C. A to C, right? Move this 2 from A to B. Move this one from C to B. Again, let me restart, then you understand. So this which is printing out from this line, right? Move this one from A to C. Right? According to this statement, n minus this from A to C. And then we're going to say this n from A to B, which is this one to B. And then we're going to do n minus 1 this from C to B. Right, from C to B. Right, so that's, we just complete that 3, right? That's why it's printing out that way. Now we're going to do again. From this 3, like move this 3, repeating, start over again, from A to C. Right, so that's the first one here, from right, A to C. And then we have to move, can we remove A to B? Nope, because